In this video, we'll be talking about the properties of convergent series. Now, it's important to note that these properties only hold true if you can already conclude that the base series that you're working with is convergent. So what we're going to do to start off is then assume then that if I have a series a sub k, and that again is an infinite series, which I will rewrite as without the bounds. Now, again, that means that if I write a series without bounds, we have to assume that those bounds start at 1 and go off to infinity. So if I'm going to assume that this series converges to A, okay, A sub k converges to A, then I can also look at a B sub k series such that it converges to B. So these are values, A and B are just numbers, but A sub k is the sequence of values such that I'm adding up all those terms to make that series. Same argument can be made for B sub k. Now, the first property of convergent series is that if I have some kind of constant multiplied by the entirety of the sequence inside that series, inside that sum, then that constant mathematically can be pulled out. Now, that mathematical logic should hold true. Again, anytime that I have a constant inside of a series, I can pull that constant outside of that series as long as that constant is being multiplied by everything inside. So if I can do that, then this series A sub k is convergent to A, and therefore this starting series of C times A sub k is actually convergent to C times A. Again, C being some constant. The next property that holds true is that if I take two series that I know are convergent and I add them together or subtract them from each other, then I should end up with a convergent series overall. So again, I can separate series over addition or subtraction just like I did from here to here. And you'll notice that this thing converges to A and this thing converges to B. So overall, this whole thing converges to either A plus B or A minus B, assuming on what we have for A plus and A minus. The third and more complicated, you'll notice that these two properties here are actually more logical and mathematical in nature. Again, I can factor out the C, I can tear apart the summation over addition or subtractions. They're mathematically logical in nature. This one works more in the concept of basic logic and how numeral values and terms work. So for this first example, if I have some value of a series k equals 1 to infinity of A sub k, and I know that that thing converges to A, then we can also say that if I start somewhere a finite number of terms down the line, then the series of k equals m, some number, to infinity of A sub k will also converge. It's like saying I have a set of terms here, and again, the series we know is just a set of terms. So if I do something with these sets of terms and they slowly add up to a value specifically such that the end-all result series will converge. Well, if I know that all these terms, this value and then this value and then this value, all the y values, if I add up all those y values and it converges to a number A, then it shouldn't really matter. Now, this is key to understanding, is that if I remove, say, the first four terms and I don't start here, but I start here, then we can definitively say that if the original series starting from 1 converges, yes, it converges to A, but it converges, then we can conclude also that if I start somewhere else, if I remove the first 4 or 5 terms, or a finite number of terms, again, it could be 20, it could be 100, but it has to be a finite number, then k equals m to infinity will also converge, but not necessarily to A. And that's important to state, that it converges, but it doesn't necessarily converge towards the value of A. It could come close to it, it could come really close to it, it could be it exactly. But if I remove a certain number of terms in the beginning of this series, I can't guarantee it will converge. The same can be said for a divergent series. So let's introduce now k equals 1 to infinity of C sub k, some other series, and let's state that that thing diverges. If that thing diverges, then the same kind of pattern can be made. If I go ahead and have a bunch of terms here, but I know that these terms will never actually condense down to nothing, and you keep adding more and more values to it, then I know the series as k equals 1 to infinity of C sub k diverges, then that means that if I start 20 terms, 100 terms, at any number of terms later, then C sub k will still diverge no matter how many terms I remove from the beginning of this series. So these are the three main properties of convergent series. Again, assuming that I know that a series converges, then this is then also true. One other statement I do want to write down here, and I stated it verbally, but I want to make sure that I write it down, is that the series of k equals 1 to infinity of A sub k equals to A does not in any way imply that the series of k equals to m of infinity of A sub k equals to A as well. This is, again, does not ever conclude that this is also true. Me knowing that this thing converges implies that this thing converges. It does not imply that they're the same thing, because again, you've removed a certain number of terms. The value of adding up all those terms will not necessarily be the same.